Hello everyone, welcome to DevOps Info channel. Today we are going to talk about the introduction of the AI. Yes, we are going to talk about the introduction because I feel building a strong foundation in AI is crucial for anyone venturing into this field. Since AI is also new to me, and I thought to just share the introduction about the AI in this video. So this will be the fundamentals to know and learn more about the AI models and how to utilize them. So when we talk about how AI was evolved, it was found, you know, in the early foundations from 1930s to 1950s. Like the first was it was found in the year 1950 by the British mathematician called Alan Turing. He laid the groundwork with this concept of a universal machine capable of performing any computation. Talking about Alan Turing, he was born in England and he lived in the period from 1912 to 1954. He basically proposed an experiment that became known as Turing test with this name. So, attempt to define a standard for a machine to be called as an intelligent. Like this was something like how, like if a machines can think, machines can do computations like human. So that was the first test which he proposed. It was Turing test, and if the machines can think and the machines are capable of performing any computation. And later, uh, the term artificial intelligence was coined by John McCarthy in the year 1956 during the Dartmouth workshop in the Dartmouth College. So, post Alan Turing's turn, Dartmouth, uh, term the coined the term artificial intelligence, and he created a Dartmouth workshop in the Dartmouth College. So basically, this workshop brought a lot of experts to explore and define the concept of this artificial intelligence. So this was an intensive 6 to 8 weeks of intense collaboration, and they laid the groundwork for what would become a transformative field of study. And after this, there was the symbolic AI, where it's a subfield of AI that focuses processing only on the symbols, not on any numerical data or alphanumeric. So it was only a symbolic interface, artificial intelligence that was focused mainly on manipulating the symbols. And post that, the AI winter, which came into the AI winter they call it in the period 1970s to 80s, it slowed down because as like this is a new field which is evolving. But during that time, the expectations were very high and the computational powers was limited because you could imagine what were the computation powers in those in those 1970s to 80s. So as a result of this, this progress slowed down, and then as we know, the AI can be computationally demanding because of the data manipulation, the deep learning, and all the stuff it does. So though the concept was there, but because of the limited computational power, it was not going further. That was called as the AI winter in 1970s to 80s. And later, the machine learning renaissance came in 1990s to 2000. So machine learning renaissance gained prominence, emphasizing the data-driven approaches. So this is where the neural networks, the decision trees, the support vector machines became popular. So if you have not seen our previous video where we talked about the large language models, we have also explained a little bit on the neural networks and the vector models. I highly recommend to take a look at it. And later in 2010, the deep learning revolution came into picture. So here it's like they built the convolution neural networks, recurrent neural networks, and a lot of new things which came like image recognition, natural language processing, and more. So all these things came in the year post 2010. This is the deep learning revolution. So as a result of that, you see all the AI applications expanded in a lot of fields. Like for example, there are some self-driving cars, virtual assistants, and medical diagnostics, and a lot of things. So as a result of that, we are able to apply the AI into different fields. And now going to talk about AI in the whole, because AI, as we talked about, it's uh, making computer to think, respond like humans. So it composes of these components, which makes it as a AI. The first one is called the machine learning. So like this is an algorithm that allows computer to learn from the data and improve their performance over time. They can recognize patterns, make predictions, and classify the information. For example, you can analyze the consumer behavior patterns that helps companies to tailor the marketing strategies. And the next one is the computer vision. In the computer vision, we are giving options for the computer to visualize like humans and then explain about what it predicts. For example, these visualizations for the computer might be through a camera, a sensor, or even a mic. So these applications include the facial recognition, the object detection, and autonomous vehicles. A classic example, which is given in the Microsoft Learn website, this is Eel, an agriculture technology company which is based out of Australia. They uses sensors, data, and machine learning to help farmers make informed decisions related to weather, soil, and plant conditions. Because the data with the sensors, they will be able to detect, okay, when is the rain, when is the dry season, and how the the crops are growing, how the crops are stagnant. All these things they are able to detect with the sensors, and we are giving the computer the vision capability. With that, it collects the data, and with the data, we are using a machine learning to predict the outcome. So this is how it works with the computer vision. And the next one is the natural language processing. The natural language processing enables computer to understand and generate human language. Like it involves tasks like sentiment analysis, language translation, chatbots, and speech recognition. So basically, the NLP models learn from vast amount of text data. So when talking about this example, we talked in the previous LLM, large language model concepts. We had encoder, decoder, and we also saw BERT, which is used in the Google. So, for example, you can predict the customer reviews. You can use the customer reviews to predict the sentiment of the purchaser overall from your product. For example, if you're running a supermarket, so the supermarket collects reviews for products from different channels, like through the emails, through handwritten notebooks, and also from their websites. So all these data can be fed into a common location, and then the transformer model can analyze these reviews to determine the sentiment, like based on the positive feedback, negative feedback, or neutral feedback. So this will help to improve the product offerings and also the customer satisfaction, because you have the data, but it is present scattered around everywhere. So you're collecting it, putting it in a location, and you're using a transfer model or a BERT model that could analyze these reviews to determine like how the customers feel about your product, which is very good, right? Um, and the next one, we're talking about the document. Yes, the documents is also a very important thing over here, because handling large volume of documents is very much important for any business. And the A can extract relevant information, classify the documents, and automate the process like invoice processing. For example, uh, they use the optical character recognition. This model uses the powerful OCR capabilities to process various invoice formats, including images, scanned documents, and digital PDFs. Like for example, with scanning all these things, they could pick up the customer name, the address, the phone number, the billing dates, the due dates, due amount, the product sold, how much product has been sold on. So with this optical character recognition, like scanning the digital PDFs, documents, they'll be able to analyze this data. It sounds like simple, but with this, they will be able to do a lot, yeah, with optical character recognition. And the next one is about the knowledge mining, extracting valuable insights from unstructured data, such as text, images, and videos, is essential. Yeah, I also talked about the previous example, supermarket, where the data is coming from different locations. The same thing you can take, like imagine similar, like a clothing store that receives customer reviews through various channels, online forms, emails, and handwritten notes. These reviews contain valuable feedback about the product quality and the customer service, and also the overall satisfaction, like about the products or the clothes that have been sold. But you see, the data is unstructured and it's scattered everywhere. So with the AI model, like you can store this in a central repository, and then you can extract the text. And with this, you'll be able to see the customer's sentiment based on the reviews they have given, positive, negative, and neutral. This would, definitely help in improving the products and the type of clothes, that needs improvement, or the type of clothes that has been sold more. For instance, you have issues with the delivery, so delivery of the products. So all these things you will be able to analyze from this data. And the last one is the Gen AI. Yeah, this you know is helpful in creating you know like for example with the Gen AI, you'll be able to create the customer chatbots. You can create customer support agents for your application. With that, it will be able to help you in understanding what are the type of the request that is coming to your uh, like to your product, and you'll be able to improve it. So, so this is how the AI is composed of. So when you can think about the artificial intelligence, it is consists of this machine learning, computer vision, the natural language processing, the document AI, knowledge mining, and the Gen AI. So all this comprises together is called as an artificial intelligence. So going further, you're talking about the machine learning. So in the machine learning, first thing is like the data is the foundation for the machine learning, because machine learning starts with data. The data can be, a text, numbers, photos. So this data can come from various sources such as, images of people, sensor readings, bank transactions, sales reports. All these things are considered as data for the machine learning. So the more the diverse, relevant the data, better the machine learning model can learn. And the next one is the finding the patterns. The finding the patterns is like we're going to, like the machine, we have got the sanitized data, and the machine learning algorithms analyze these data to find patterns and the relationships. Like these algorithms use statistical and mathematical techniques to find the insights of the information that it can take out from the data. For example, they might identify correlations between certain features like length and the species in the wildflower samples. This is also a very good example which you could see in the Microsoft Learn website. And the next one is the model training, because first one, you have sanitized the data, you have you have the right patterns of the data, and the next one is the model training. So in the model training, the algorithm adjusts its internal parameters based on the data it receives. Like this process is called model training, because it has built this algorithm now. Now it will adjust its internal parameters based on the data it receives. So this is training the model, because like you have data first, you find the patterns, and then you're training the model. You see the output. If the model is not coming based on your requirement, then you need to change your data. So this is how the model training happens. So as the model trains, it becomes better at making accurate predictions or classification. And later it comes the model creation. Once you have trained the model based on your requirement, the algorithm will encapsulate, finding its own model, and this model can be used to make predictions or decisions. So for example, the example what we have in the Learn website, Microsoft Learn website, in the wildflower example, the model can identify the correct species for the new samples based on the length, based on the color, what it has been collected. And the last one is the applications and the limitations. Yeah, machine learning is used in various domains, from chatbots, predictive text, to medical diagnosis and a lot of things. Um, it's still in the learning phase, so always you should see its limitations, train it, and then see how it is helping you in your scenario. And going further, we're going to talk about what are the machine learning offerings that comes in the Microsoft Azure. So the Microsoft Azure provides the Azure Machine Learning, a cloud-based platform for creating, managing, publishing machine learning models. Like Azure Machine Learning Studio offers multiple authoring experiences. Like the first one is the automated machine learning. This is suitable for beginners. This feature enables anyone to create an effective machine learning if you have a data. The first important thing, if you have data. And the second one is the machine learning designer. Like this is a complete graphical interface, no code development. You can be used for the machine learning solutions. And the third one is the data metric visualization. You can analyze and optimize whatever the adventures you do with the visualization. And the last one is the notebooks. This is for the developers. You can run and write your own codes, and then you can analyze your data. So this is the example you see on the Microsoft Azure Studio. For example, if you see the data assets, these are the default data assets we have already in the machine learning, like Wikipedia, the weather, the restaurant ratings. So these are the default ones which is already present. And also you have some components. So based on that, you would be able to use it. Uh, I'm definitely going to build one machine learning model, which we can talk about it, but still it is in the development phase. Once it is completed, we'll have a demo. So the next one for we are going to talk about is the document intelligence, because Azure AI document intelligence is a powerful cloud-based service that also helps data processing from various types of documents. Like for example, if you have a text extraction, the Azure Document Intelligence extract text, key value pairs, and tables from documents, forms, receipts, invoices, ID cards. So here the best part is you don't need to have a label. No manual labeling is required. You get the structured data without intensive coding or maintenance. The best part is it already had some pre-built models. Like for example, we have the pre-built models for invoice, receipts, identify the documents, health insurance card. So these models can extract information from IDs, receipts, and invoices. And also, if you want, for example, if you want to create custom forms, that is also possible. So you can use this Azure AD Document Intelligence to turn your unstructured documents into usable data. Like for example, when we talked in the previous about a supermarket store, a clothing store, you can definitely use this Azure AD Document Intelligence to structure your data, and then train your AI model, and then you'll be able to collect the feedback about your product. So this would be really helpful, but you need a little bit of thinking based on your model, based on the model, based on the data, and how are you going to use this. The next thing is like the use case. Yes, the A here, it can be definitely beneficial in the healthcare, like a assist in diagnosing the diseases, because it has a large amount of data. It can analyze medical images and even recommended therapies, like based on the medical images from the previous cases, from the previous histories. It can analyze it and also give you the recommended therapies. And the next one is the accessibility. Like it, AI power tools enhance accessibility for people with disabilities, from speech recognition. Uh, this bridges the gap and empowers individuals to live fulfilling lives. There is also a very good video in the Microsoft Learn website about this. I recommend to take a look at it. And the next one is the smart infrastructure. Like cities use AI for traffic management, energy optimization, and waste reduction. So these things can definitely utilize. We can utilize the smart infrastructure. Like for example, the traffic management, you could see how much is the traffic flow in the peak period in the morning, for example, how much is the traffic flow in the evening, how much is the traffic flow in the afternoon. So based on this data, AI would be able to give you uh, you know, and output and the efficient traffic management would be able to do in the city. So this is one of the example for a smart city using AI. And the environmental conservation, it helps monitor ecosystems and also predict a few other things, which is good. And in the entertainment, it's very nice. It gives the recommendation algorithms on streaming platforms like YouTube, Instagram, making our entertainment experiences more tailored. For example, in the YouTube, you keep watching a video on a particular sports, let's say cricket, and then it builds the algorithm and gives you all the videos related to the cricket which you can watch. So this is also very good for the entertainment. So last but not the least, we are going to talk about the summary. So A is, of course, it's evaluation. It's a right now it's a developing model. So it's always better to build any A model with fairness and bias, because techniques like fairness aware machine learning and debiasing algorithms can help to address this. And the next one is the transparency and explainability. Users should understand how AI systems arrive at their decisions. So, for example, there is explainable AI. This method provides insights into model behavior. That's also very important. And privacy and security, AI systems often process sensitive data. Yeah. So protecting user privacy and ensuring data security are very key important points here. And the next one is the accountability and governance, which is very important. We have to establish a clear guidelines for AI development, deployment, and monitoring is essential. So all responsible AI frameworks, which is depending on your region and regulatory bodies, everything needs to be, checked, and then proper accountability needs to be there in place for it. And human AI collaboration, yeah, it's, AI is collaborative system where humans and AI work together, and that will definitely lead to a better outcomes. And coming to talk about the long-term impact, consider the long-term effects of AI deployment. So you should actively work to minimize any negative impacts if you're building any particular AI solution. And education and awareness, educating the users, policymakers, and the public about AI capabilities and limitations helps the AI foster options. So remember, AI is a powerful one, but it's up to us to yield its responsibility. So by adhering to this principle, we can create AI systems that can completely benefit us and the society as a whole. Hopefully, you enjoyed this video. Thank you, and see you in the next video.